So this is Pong. Well, it's Video Olympics, same deal. Hit game from the 70s, full of exciting action. It's all they had back then. Fun hadn't been invented yet, don't judge. But anyway, even these primitive games had a fair amount going on behind the scenes. Like the ball. Watch the ball. See that? It bounced. I know, right? But also, it bounced. How did that work? In the real world, physics just makes this happen. It's a built-in fact of the universe we live in. Behind the scenes, Newton just makes things work, it's magic. In a game though, some poor programmer needs to write code to simulate physics. But physics code is notoriously difficult to get right. We're not writing a physics engine from scratch, just yet. My grade E in A-level physics and GCSE maths just won't cut it. This is Gamedev The Hard Way, not physics for the insane. In this video, I'm going to add simple collision detection. Plenty of games in the 80s and 90s got by with the techniques that we're exploring today. And along the way, I'll get distracted and accidentally make a weirdly fun but very, very bad game. Will it be as bad as Video Olympics? Oh, I hope so. So games aren't real, oddly enough. This means everything that happens needs explaining in code. Moving things around the screen is fairly simple. It's just a bit of basic maths. We have a velocity, we have a position. To work out where the player will be next frame, just add the velocity to the position, job done. But what if the player moves straight into the path of something bad? Well, that's where we need the power of axis aligned bounding box. Yes, quite. But it is quite a big deal. Here's how it works. What if I told you the visuals of a game bear little resemblance to the mechanics and code happening behind the scenes? That your computer isn't looking at the objects moving on the screen to see if they collide. In most 2D games, the player and other objects are really a square or rectangle as far as the computer cares. And with some minor maths, we can work out where and if two squares overlap. You can see that as I move the box around the screen, the code is calculating how much of the X and Y positions of the boxes overlap. If they both overlap, then logically the boxes themselves are overlapping. This is all the code is doing, it's just constantly measuring these two distances and working out if they're both greater than 0. I know Mario or whoever isn't square, but from the computer's point of view, that's all a sprite really is. There's a bounding box that's used for collisions with a pretty image drawn at that position on the screen for the player to look at. Last video I introduced the idea of components. This concept is becoming really powerful, mostly because it forces me to stop gluing bits of code together. To implement collision detection, all I need is a collider component, which just needs to store an active flag to say if this entity ID is using a collider. A collider type, and currently there are rectangular collisions, but later I'll add circular ones. And this is just defined as an enum. There's then a union, so that I can store the collision shape. After that is a flag to say if a collision has happened. And then the entity ID of who this one collided with. This is used by a collision system that first clears out all the collision flags in that frame. Then, for each entity, it just does the AABB test if both entities contain rectangle colliders. Or it does a circle intersection test if both entities contain circular colliders. If there's a mix of two colliders, well, anyway, moving on, let's see this running. So if I move this, you can see that when the red box, which is me, gets touched by a green box, I go yellow. The other box also goes yellow, but it's so fast you can't really see it. But there, that proves that the game system knows that collisions are happening. We are slightly closer to making some sort of very crap game. There's a few problems with this method, which I'll be conveniently ignoring today. Things like, not every character in a game is actually square. And it feels unfair if the player is too easy to hit, or the enemy is too difficult to hit. In more complex games like Mario or something, you might need to know whether his head has collided with something compared to his feet. We get around some of these problems by not using the size of the graphics as our bounding box, but instead defining a separate collision shape, or multiple collision shapes. We can then make this smaller than the graphics to even out the edges. And once you realise the size of the collision box doesn't need to match the size of the sprites on the screen, you can get creative. Make it tiny compared to the sprites so the player feels really skillful as they slip between bullets in some insane bullet hell shooter. Or get distracted and die. This video was brought to you by my amazing patrons and subscribers and people like you. If you like what you've been watching, I hope you'll consider subscribing. Unlike Adobe, my subscriptions are free. But if you do want to donate to the channel, I've got a Patreon and a Ko-fi. The links are in the description. If not, it's fine. I'm not going to hassle you. We all know how YouTube works by now. Let's just carry on with the video. Let's go on a side quest to make this code a bit less confusing to understand. I don't mean the lines of code on the screen. I mean the output of the program, the shapes being drawn when the code runs. Because looking at two green squares and a red square is getting a little bit confusing. I can't quite figure out what's going on. It just occurred to me whilst I was looking at this code that I'm just randomly choosing a colour for things based off what registry ID they get given, plus 1 so that they don't turn up black, because you can't see black on a black background. And then I randomly chose 48 just as a test if it's collided. Now, in the real code, what we'll have instead, there will be the actual bitmap IDs for the images that you will see as the sprites. Because this is still in debug code and I've not drawn any images and not even made image loading work, I just need a way to have different coloured rectangles so that I can tell things apart without having to remember that green is probably the player and red is not the player, or the other way around. So if I make a new component, I can do that. So we will have one that I'll call debug draw. That'll do. And I'll just copy all this stuff, paste it in here. We now do hash fragment. That's a weird name for something because you can't have debug draws. Debug sprite. So then we need the C version. And again, all I do is I find one of these that looks simple and I copy it and I paste it. Someone in a previous video's comments asked me where all the actual data for each of these components is stored. It's stored inside the C file here. So there, that is an array that will store all the entities information for the debug sprite component. Every time I include this file, I'm giving access to it through that extern. To use it, I just need... Now I don't know what colours there are, like, just give me a minute whilst I find the Agon Light colour palette. In my code, I'm using mode 136, which gives me 320 by 240, 64 colours. That's 60 Hz. But what exactly are those 64 colours? Because I don't just want to pick a random colour out my head. So we need to find out what these 64 colours are. Inside the Agon Light Bitmaps and Sprites API, it tells us here that it uses 64 colours RGBA 2222 format. So 2 bits for red, 2 bits for green, 2 bits for blue. So we should be able to find a colour palette that matches that. Okay, I think I've found one. We just went on a crazy ride around the internet. So if you search for 64 colour RGB 222 format palettes, you can get on Reddit and Garmin watches 6 years ago. Thank you, Steve's dad. He wanted to know how to do it for his Garmin watch, and then this random person 6 years ago sent me to the Low Spec Palette website, which I can remember existed. This is all the colours, all 64 of them. And we can probably confirm that by picking certain colours from here and using them. Why the Agon only does these colours is hardware based. There's certain resistors on the VGA connector that are physically wired up to generate these specific colours. That's how it works. You can't change the colours. There's no bigger colour map or palette that you can pick 64 colours from. You get exactly these colours. which means any games that I create are going to have a certain style to them. Now you don't specify RGB colours, you just do a colour index. So I think I want to make my sprite bright red. In here, bright red is this one. Colour 11 should be bright red. And then I think we will change the colour of the enemies to be a different colour. I like that Kate warns me that I've included that and I'm not actually using it. I don't like that I get lost in my files and I'm just sort of like poking around trying to vaguely remember what I was doing last. Even though it's up here. I'll collect lots of tabs up here and never click on a single one. There's probably a window switching key combination to change between the two windows. And I've just realised Control Tab does it. Suddenly my editing has become a lot easier. And let's go for something that looks obviously different. So we're creating the enemy, we're setting the colour. We now need to go into the debug draw system. Else the colour is going to be not that. It's going to be the colour. I just set the colour not. So let's see if that even compiles. Oh, it does. You're not the colour I thought you were. I mean, that's yellow, which I think is what I said it should be. No, I said that should be red. So right, this colour palette doesn't match. Okay, I've just temporarily butchered my code quite a bit. So I've got this draw grid function in the game state, which just draws boxes across the screen. So I've got 64 of them, neatly spaced across the entire screen. Then I've commented out the entirety of the game draw function to just draw the grid. And then I also turned off clearing the screen because it turns it into a horrific flashing mess. If I now run the code, ignore that. Weird emulator thing here, watch this. Whoop. There we go. So there we are. These are the 64 colours. I need to screenshot this and keep it. Should be 14. That's better. And that's not yellow, that's blue. I don't care anymore. It's kind of working. I ought to get on and make something now. There we go. That's a bit better. Now I can more deliberately decide what colours there should be. And if I change the sprite definition, I can change the size of the entities so they don't all have to be identical looking squares. We are approaching Atari 2600 levels of quality now, just with 100 times more complexity. So it's one thing having components, so that the systems can communicate with each other. The physics system moves things, collision system detects collisions, mystical undecided systems react to the collisions, and so on. But on top of that, the game itself needs to know when certain events occur. Like the player dying, or any collisions happening. Somehow, at some point, I'll probably need to play sounds when that kind of thing happens. And I won't want to fill the game with a random call to play sounds everywhere. That's just really messy. The Game Programming Patterns book has a useful section on decoupling patterns. The event queue will be useful. What it'll do is separate the creation of an event from when it's processed. And here's a good example from the book of how it might work. So if the game needs to play sounds, I mean mine doesn't, but it will do one day, I don't want to put loads of calls to some global play sound function everywhere. I mean, I don't have a modern multi-core CPU like it says here, but the idea is the point, not this specific example. Why should my collision system need to know the sound system exists? Shouldn't even know sound is a thing. I could also make use of the observer pattern too. This is a mechanism where one piece of code can announce something happening and it doesn't care who receives that notification. The example goes through putting achievements in a game. It's a useful concept. The event manager sort of evolved while I was writing it. Once I understood the idea, it wasn't too complicated getting the basic idea working, but then I sort of expanded it into the system I'm going to explain next. As I write more of this code, I'm finding there's moments where I need to sit down and carefully plan out a new feature to ensure it fits with the existing code properly, and isn't some hacked together rubbish like before. But then there's other times where I just need to like write things down and see what happens. But my general rule is to try and keep everything decoupled. The event manager, for example, doesn't need to know anything about components, collisions, or that it's even part of a game. I could literally rip this piece of code out and use it in anything else. I'm doing this with my favourite C programming feature, function pointers inside structs. Right, I'll keep this brief, as there's not much going on here. We'll begin with the header. And hey look, I'm using the pragma once thing. I knew it existed. I'm just so used to writing code for ancient compilers that I forgot it existed. There's an enum for all the different kinds of events that the manager can handle. After that is a struct to hold an event. It just stores the type and then some data relevant to that type. Then inside the event manager, we've just got 4 functions and that's it. So inside the C file, there are some extra pieces that are private to the handler that I needed to make it work. There's the main event queue that can hold up to, I've just randomly decided, 255 events. 255 sounds like a good number. There's then an array of what I call subscribers. That's what the other parts of the game engine are to the event manager. If you want to know an event has happened, you become a subscriber to it. And what you do is you subscribe to an event by registering an event handler for whichever event you care about. So in the subscribe function, all we're doing is checking that that particular event hasn't got too many subscribers, and then adding your function pointer to the subscriber array. And emitting an event is even simpler. We just add the relevant event to the event list. The whole system is kept running by the dispatch function, which just goes through the event queue, and for each event, runs the callback function each subscriber is registered. To use this, all I do is add a tiny bit of code to the collision detection routine to emit an event collision event. And then over in my completely separate main game state that has no idea that any of this exists, I can just subscribe to the collision event and for testing pass in this little event handler that just increments the score. Everything is separate, nothing knows about each other existing. It's really nice. So now, if I run the game, and you watch the score changes every time something collides with that item. It's not called an item, is it? It's called an entity. So every time the moving things collide with me, the score goes up. Oh my god, look, I made a thing, this is awesome, look, it bounces, whoa, look at that, oh my god. Yeah, that's so cool, bounces off the top as well. And then you hit the side of it and it just bounces straight back up. Look at that, wow. Wonder if I can catch it with the side. Nope, you can't knock it sideways. Okay, so sarcasm aside, slightly, that is pretty cool. And since I now appear to be accidentally making a Pong variant, this is an excellent chance to add pointless weird functionality to my code. In Pong, you see, you can hit the ball on the corner of the bat to influence where it goes. It stops that thing that you've probably discovered in really bad Pong clones, where if you hit the ball perfectly right, it just bounces straight back at you, or you could get the ball stuck, and it's impossible to actually hit anything else. Kind of think like really bad Arkanoid clones where there's one brick in the middle of the screen and you just can't hit it because there's literally no way to get the ball into that area. I kind of need that way of directing the ball. I'm not making Pong, but I am having a lot of fun writing code. I want to make it do that thing as well, just as a bit of an exercise. The general logic is to find out what side of the bat it collides with. And then what we know, because that's bodging things to make them work for this specific game, that I'll no doubt throw away by the end of next week. No, we need a generic way of doing this so I can reuse these ideas in the future. I know I said I wasn't making a physics engine with my E-grade A-level physics knowledge, but I think this is the difference between actually crap 1980s games and fun crap 1980s games. In the fun ones, things didn't just slide around the screen like they were following predefined patterns. They interacted with things on the screen. They maybe had a bit of inertia to them. It felt a bit more realistic. So we need to improve the collision system a bit. Back in our collider component, a few things have been added. There's the ability to have different physics bodies. There's a dynamic body, which obeys what I'm loosely calling physics because it's got velocity. There's a kinematic body that's under the control of code, but can collide with and influence dynamic bodies. And then there's a static body that doesn't exist yet, it's just in there for completeness. In the collider are X and Y normals, and we'll get onto those in a minute, because there's nothing normal about this code as you're about to discover. I've then added different bounce types, and the only two of any use at the moment are called uniform and Pong. Uniform collisions work like they did before. Speedy thing goes in, speedy thing comes out. Pong ones are a little bit more exotic. The direction is called the normal, and it's just a reflection of the vector that they came in at, kind of 90 degrees to the surface. In a proper physics system, this involves very complex maths. In a simple system, you just swap the signs of the velocity vector and away you go. It kind of boils down to the same maths either way. We store this normal vector for later, because now we've detected a physics-based collision, we need to answer the question I asked right at the start of the video. How do things know they collided? The code now contains not just a collision check, but also a collision response. With a uniform collision, the normals are used to work out what direction the entity should bounce off in. This is how we make things appear solid in a game. You just swap some velocity vectors if there's a collision. That's it. That's like the big secret. If it's a Pong collision though, what I need to do is work out if it's a vertical or horizontal collision. Then work out how far from the middle the collision is and bounce in an appropriate direction. So if you hit something on the left, it bounces off to the left. Hit it on the right, it bounces off to the right. Hit it in the middle, it just goes straight up. It's completely fake physics. The world does not work like this. But it's a video game, and it's kind of fun in some situations. Like when it breaks. Bounces off the end and goes boing, and goes insane. No. Not quite correct. Oh, it's going back down. What's it going to do? Yeah, it's going so fast it now doesn't even know it's going through. It's going faster and faster and faster and faster. Things have definitely gone wrong. You know what's kind of weird? This Pong thing is weirdly distracting and sort of fun to play with. Like, I know it's just a square that moves around the screen and there's another square that kind of looks like it's bouncing off it. But compared to just moving a sprite around the screen and that's all that happens, that little bit where a thing reacts to my inputs suddenly makes it much more interesting. Go make games yourself. Don't try to make the next GTA 5 or Doom or whatever. Go make some malformed crap that doesn't work outside your IDE and needs very careful input so it doesn't crash or go insane. Because you'll spend literally tens of minutes being distracted by a turd like this. But you will think it's amazing because it is, because you made it. It's like if you played it made by someone else, you'd be like, what is this rubbish? I'm not going to play it. But because you've created it yourself, there's this extra level of interest to it. You kind of get ideas about what you can do next. But again, I need to keep writing generic code and not specific to Pong ideas in the middle of random videos just because my brain went off on a tangent. I think I said I was making a roguelike, which doesn't even have physics. What are we doing? Now I can bat the ball around as I want. There's an element of skill here to control the bat and move the ball. Is it a bat really, given it's a giant box again? And, you know, there could be a game in here somewhere, maybe, if I play with this enough. And I remember what I said, that we're not doing physics for the insane? Well, see how I can trap the ball in the bat? Yeah, fixing that kind of stuff gets very hard very quickly. So we're not going to do that today. To fix that, we'd need to do more correct physics. And that's not where I'm going on this machine with this mini game engine. That we call feature creep. So what is next anyway? Well, not going down rabbit holes and introducing random functionality into the engine might be an idea. Maybe. But considering you thought you were going to watch some video essay on collision detection, the random detours are actually a bit more interesting, aren't they? I think the best idea is to create some kind of game based on what I've got now. I could continue adding functionality, but the current code needs properly testing. I've built a bunch of pieces, they seem to function well enough, but I actually want to make something that is a kind of game. I think I've got enough in this mini engine to do basic Atari 2600 style games. The first task, however, will be to think up a structured way to manage the whole game logic and enforce game rules. there's like a level above everything I've been writing. I don't want to define, for example, what the entities will be in the game and how to spawn them at certain times and all the sequencing that goes on inside a game and just like jam it in there. This should live inside a single file, probably the main game state, but in a way that is kind of reusable, and it shouldn't be smeared across the engine code itself. This is that bit where I need to go away and figure things out, like how do I define a level? What even is one? So that's what I'll be doing next time, figuring out these kind of fundamental ideas of how to sequence the game. So until then, I'll see you next time.